It's great to see there are so many people still in the audience, staying through to the end. I hope we're going to have a really interesting panel discussion here, because there's been quite a number of comments, I think, through the day so far that chime a lot with, I think, what's important to the manufacturers that we've got represented here. And I'll do a quick intro again, just so you know who they are in order in a moment. But there was a couple of things I kind of wanted to reflect on from earlier in the day. At the very start, we heard Minister Backers talk about how key European security is, and the role that space has to play in that. And I think what's quite interesting is, it's not just about the hardware that we put into space that's really key in terms of our security, but having an industrial process and an industrial supply chain and manufacturing capability and the security around that is actually key as well, because if you haven't got that secure industrial base from which to develop the things you need, then you can't have that hardware that goes in. And I think there's a bit of synergy there, making sure that we've got the industrial capacity and capability that we need. And the other things that I think have come out that are quite interesting from Stacey, who gave I think one of the second briefs, and Sasha as well, was about innovation. And how do we meet the future challenges that we've got in terms of not just the ability to communicate and the capabilities that we need to do that via SATCOM, but also those other elements of space capability that we need to operate up there securely in a threatened environment. So how do we innovate at the right sort of pace between governments who need to buy these systems and industry who need to develop these capabilities in time to meet the sort of programs? And there's a bit of interplay there, I think, between government and industry that's going to be interesting to talk about, and how that innovation takes place, and what we can do to support it, meet it. And I thought the other interesting thing that came out earlier in the day as well from Adel Al-Salah from SES was about how some commercial operators now are looking at the potential of putting on space domain awareness capabilities, RF monitoring, probably proximity sensors and those things into commercial satellites. And a sort of very poor analogy I've always thought about in this respect is you wouldn't deliver a modern computer network without antivirus and cyber controls and firewalls and those sorts of things. And we know that a whole spectrum of space capability is now threatened, particularly if it's carrying government traffic. So we do need to look at perhaps hardening not just the government-owned capabilities, but those commercial operators' capabilities as well. And how do we do that? How is that being done? And what role has government got in supporting the development of those sort of things? But also, how do we make it affordable, cost-effective, and dynamic, and those sorts of things? So some interesting things to reflect on there. And in terms of what we're looking to discuss, what we thought would be interesting is to look at how modern manufacturing organizations are sort of adapting their strategies to develop, to sort of balance that need for innovation, but also cost effectiveness, because these space systems are extremely expensive. So how do we make them? How do we make the right sort of capabilities accessible to meet those requirements that we've got against threat, taking in new developments in technological advancements rapidly, and those sorts of things, but also how do government customers perhaps compare to the commercial sector? Is there anything that we can learn and explore about that? So we'll look at some of those issues. And also, again, something that's particularly close to home, I think, for the manufacturers is, some of the near and mid-term issues around the supply chain. How do we get the right sort of manufacturing expertise and knowledge into these organizations, and manage the need for SQEP in the right areas within that industrial base? And again, is there anything that governments and many of the people that are in the audience here from the government side, what can they do in terms of policies or strategies to support the manufacturing base? Because, like I said, having a secure manufacturing base enables you to produce the capabilities that you need to put into space. There's a bit of synergy there. And then, not to overdo it, but a common theme throughout the day has also been the threat, and how do we respond to that, and how the manufacturer is approaching those threats. And there's some differences. Obviously, we've got Don representing Kuiper, who will have some different views because of the business model to maybe some of the other manufacturers, and we'll try and pull out some of those differences and explore things. And if anyone's got any questions, then please feed them in. And I might have a question for Clint as well. I see him sat in the front. Bring him into it. So just to quickly run through the panel again, we've got Dave Powell from Northrop Grumman, Don Brown from Kuiper, got Mickaël ULVOA from Thales, John Parkinson from Lockheed Martin, and Dave Phillips from Airbus. And we'll just have to make an excuse for Dave because you've got to get on a flight. So around about 6 o'clock, he'll turn into a pumpkin and disappear off the stage. So apologies for that. But so going back to the sort of the beginning there, what I'm interested to understand is how are manufacturers these days adapting your manufacturing strategies to balance that need for innovation that we've heard a lot of coming out of Luxembourg and all the initiatives that are going on here, along with making it cost effective, rather than expensive bespoke systems. How do we balance that need and also adapt to the rapid technological changes that are going on? So perhaps we can start with Dave for Northrop to look into some of those points, and I'll bring in some others from the panel to discuss that as we go through.
Yeah, absolutely. Thanks, Dave. So at Northrop Grumman, we build a range of different satellite buses. So everything from almost sort of commercial LEO standard right through to fully hardened GEO. And we're seeing different requirements from different customers. And I think the secret for us is really to be agile in the way we're manufacturing. So we can do that, the bespoke, multi-band, highly hardened, complex satellite, but then equally we can shift our manufacturing facility to do more of a high throughput. We're not doing hundreds of satellites, but certainly tens. That's what we're working on in various facilities. And over the last few years, we've opened up more facilities to enable that sort of flexibility across that fleet. I think the other thing we've really been pushing hard on for the last few years is that agility on orbit. So instead of launching a satellite, particularly a geo satellite, launch it up there and leave it there for 15 years. With our space logistics business, we've enabled the capability to actually put a mission extension pod on the back of a satellite. I think Clint mentioned our mission extension vehicles earlier. So mission extension pods allow us to have that flexibility to either add extra fuel, which is sort of the classical use case, or potentially add extra capabilities onto a geo satellite, which is already on orbit. It wasn't manufactured to do that, wasn't designed to do that, but through the way we work with space logistics, we can add on capabilities. So that gives that sort of flexibility post-manufacture as well.
Yeah, I'm kind of interested though with that because it feels in some way that that's been industry-led rather than necessarily customers coming with the requirement to say, hey, look, can you do this? And it'd be interesting to kind of see what your different points of view are. Where does that responsibility for innovation lie? Should it be the customers coming along, pushing the boundaries and saying, well, this, we want a step change, we're looking for these types of things? Or should it be the manufacturing industry who are saying, hey, these are the next capabilities we've developed. You need some of those. I mean, what's your view, John, on those sorts of that sort of thing?
I kind of look at this sort of from a different perspective. So I was kind of thinking last night, how can government customers help industry? So with respect to innovation, I think the danger is that some governments can be very prescriptive on requirements of what they think the, like for example, a satellite, what they think it should do, rather than asking, what is the problem, what do we need to solve? So effectively, by having very prescriptive, detailed requirements on what a satellite should do, it could stifle the innovation and not allow space for manufacturers to propose new ideas. So effectively, it filters out, especially a lot of SMEs as well. It can filter a lot of small companies out. So I think having sort of presenting what is the problem to solve let the companies go and innovate to solve that, I think we'd end up with a much better product overall.
Yeah, yeah. So I suppose another observation is how do you facilitate that? I call it like a back office engine. So, perhaps more government customers doing a more regular flow of R&D and studies and those types of things. We quite often see stuff coming out from the US SDA, but I don't think that's replicated everywhere. Although there seems to be, a lot of developments across NATO and the European landscape with innovation funds and things going on. But there still needs to be driven, I suppose, to some degree by the government users, because they're the ones who've got their own vision of where they want to go. And so, Dave, before you go, I thought I'd bring you into the chat, sort of your views on how that innovation process could work better between, that government strategy and making sure things are developed to be ready in time for the programs and
it's really,
the things that people can think about there to improve.
It's a key question. And for me, there's two. You talk about, in your original question, the two things together, the innovation and the cost effectiveness. So the question is, how do you do both? In the end, we want to keep, first and foremost, our customers happy and give them the capability they need. At the same time, we need to deliver, consistent and reliable returns to our shareholders. So we have to get both of those elements correct. And for us, it's about really focusing on products which, have a business case and an exploitation route, commercially and in terms of government customers, which is fine. We bring the products to the table. I think it echoes a little bit what John is saying, that sometimes it would be good if the government customers come and look at what's on offer and use that as a starting point rather than trying to reinvent something. We'll try and build around standards and modularity and to make things flexible, agile, scalable, and so on in response to that. I think the other side of it is there'll always be things that we need to do to respond to new threats. So you'll have the stuff that's a bit more innovative, that you need to deliver in a different way, perhaps a little more quickly, and perhaps is very specific to specific customers in that case, which is fine. Companies like Airbus can do that. We can. We've got very good engineers who can deliver, very interesting technologies. But you have to have a different way of managing that from a kind of commercial perspective. The way you initiate development, fund development of those new sorts of technologies, and then the way you contract to pull it through into capability has to be a little bit different. So I think when you're looking for asking a question, what can governments do to support? It's having the kind of flexibility to manage both of those ways of working effectively, to buy off the shelf when you need to, and when you need things quickly and it makes sense, but also to share technology roadmaps, to plan in advance, to fund, the cutting edge technological developments in a collaborative way.
Yeah. I think it was interesting listening to the briefings earlier, because there seems to be a lot of progress in places like NATO in particular, with NSIF and DANA and some of the other initiatives going on, about trying to create the environment where those common aims can be placed, so that common capabilities and technologies can be developed. But it still feels to me as if there's a little bit of a government authority will say, well, look, this is our approach to mitigating that threat, and you end up then having a bespoke solution, rather than saying collectively across a wider government environment, and maybe this is where NATO can help, is saying, well, we've all got the common threats, whether that's direct-to-sent ASAT or lasers or high-energy beams or whatever it might be, RPO operations. There's a common suite of threats out there. But if we continue to come up with bespoke solutions down a national pipeline for each of those threats, it's just going to be more and more expensive for those nations. And is there more that can be done to say, well, how do we collectively develop capabilities that we can all then draw on, and it all becomes a bit more cost effective? I don't know if you've got any views on that, Mickaël, about how we can do things more collegiately.
Yes, thank you very much. I'm very pleased to be here, because I was present in the first GovSat conferences, so I'm very pleased to be here today. Just to to make an assessment of the situation today. Effectively, we have some different threats: intelligence, physical aggression. You have IR jamming. You have also spying. And so we can imagine we have some capabilities. For instance, we can have a sensor, optical sensor on board satellites. We can also have some higher resistant jamming on board, but also we can have some effectors, laser or radio frequencies effector. And in this case, we want to have a common picture on these capabilities. We can use, it was mentioned by Guillaume Delabrosse on this morning, we can use some common project, I think, to, for instance, European defense projects. We can make some uncommon, military requirements in order to face to these streets. And then after this step of common requirements, we can, with an industry behind each MOD, we can create a new capability, common capability for Europe in order to have a common baseline. And then each MOD can use the different response to each requirements to have a specific design for the satellite of the MOD. I'm sure I was in the French MOD for several years. I'm used to this process of a European Defence Agency, and I think it is a good way.
Mm-hmm. Yeah. Well, that's interesting. It would bring us on to sort of the second question area. But what I thought would be interesting just to take Don's perspective on some of the things we've talked about, because obviously your model with Kuiper being in a different orbit and a completely different architecture, I suppose, to having large single geos dotted around. It brings a different dynamic to addressing some of these problems, doesn't it? And dealing more perhaps with network agility and resilience than it does necessarily with the platform side of things.
Sure thing. We're not a manufacturer to sell spacecraft. We're a network. We're a networking company. And so we're going to make 1,000 spacecraft a year in order to build a mesh network. And it's all about the networking. And you'll find sovereign capability in focusing on networks. And so that's why Amazon is doing this. It's to create a broadband network around the world, and for governments to provide sovereign satellite solutions that are focused on one thing, mission effectiveness. You know, you had a great point. You know, the prescriptive nature, I was in the geo world for Intelsat, PanAmSat, Telesat for many, many years. And the prescriptive nature of government saying, okay, I want you to build this thing that looks like this and acts like this. No, I want you to build something that has an effect. What is the thing you want out of that? And that's how we kind of tend to approach this business. We're a company that is very fortunate in that economies of scale drive us. Amazon is a scale networking company. It's not a delivery company. It's not a package company. It's not the Prime Video company. It is a fantastic software-defined network at global scale. And we just kind of like space hardware to provide, you know, global service, just like we like laptops on the ground.
Yeah, very different sort of model. I guess at the end of the day, you've still got to build your capabilities. And I was just wondering from a manufacturing perspective, what you all see in terms of near and mid-term challenges to manufacturing space capabilities. You know, yours perhaps different because you're high volume, slightly different in terms of, you know, exquisite levels of resilience and sensors and all those sorts of things. You know, Airbus operating in a slightly different space with different skill sets. You know, so what do you see as the challenges in terms of supply chain management, components, skill sets that you need at the moment? And given the audience that we've got, you know, are there any particular key messages you would want to get out to, you know, the governments to see what are the strategies and the policies they perhaps ought to be thinking about more to support the industry Because I was saying at the start, without that solid industrial base, you can't produce then the capabilities you need to go into space. So, yeah, go on, Don.
It's so the industrial base, a global, diverse industrial base, is essential. For all the components, we have a very healthy industrial base, and it's kind of interesting. And I work in a thing called the Devices Group of Amazon. Huh? What is that? Kuiper satellite business is within the same organization at Amazon that makes Alexas, Kindles, Rings, Blinks, all those devices. So are you all familiar with those things? I have no idea. But they're consumer devices that are manufactured at very complex in many cases. They're manufactured in scale of millions of very complex electronic devices. What we've done is we have really focused on how do you make spacecraft and terminals and network components into an integrated network at scale, building the supply chain. And the global supply chain, and everyone in this room, is incredibly important to us. And that's why that is how we look at manufacturing. Last thing I will just say is none of these people up here with me are necessarily my competitors. They're my customers, right? So I want to have a connection from a Northrop Grumman geosynchronous spacecraft that's doing a variety of Earth observation missions to use my space network. We'll be a mesh in space. You know, none of these guys are my competitors.
Yeah. Michael?
Yes, for this question, I have two or three ideas. The first is the robustness of the supply chain against cyber attacks. I think we can have some support of the governments in order to make an assessment of the cyber maturity of a supply chain and to make sharing intelligence of the cyber threats about supply chain. The second thing, I think it is important, it's the supply of the support, of the government for rare materials. I think for example, to high-strength aluminium, for example, and I think in this case, we need to have a very high support of the government for this supply chain.
Yeah. And Dave, how about you from a geo perspective?
I could echo the same sentiment, but I mean, from a supply chain resilience point of view, I mean, as a huge commercial aircraft manufacturer, you know, we put a lot of effort into mastering the supply of raw materials, for example, and various components and so on. So we're quite lucky in the sense that we can, you know, our Defence and Space division can piggyback a little bit on those sorts of initiatives. No, for us, I think it's a little bit different. It's about making sure that really you have the let's say the industrial base, you know, within our home nations, let's say. You know, for us, it's the UK, France, Germany, and Spain. But you know you know, we're working collaboratively with government to make sure not only do we have the facilities and the capabilities to do this cutting-edge stuff, not to do everything. We're not going to build a constellation to compete with Kuiper at a national level, but at the very least, you can do that critical stuff that I was talking about earlier. You know, there's elements that you need to do to give yourself, you know, protection and to have the edge in the end, and in the end to have sovereign control. So it's, you know, very much working hand in hand with government to make sure you have the facilities, the people, working with academia, with education, to make sure that you know, you're sowing the seeds for the ability to deliver in the future. And then you need you know, you need programs that pull all of that through. There's no point in sowing all of those seeds in your garden if you then, you know, water the neighbour's backyard. You know, you need to have some projects that pull all of that through in the end. So you need to do the work at the end.
Do you think? Sorry, go on, Michael.
Just a compliment. I totally agree with you about the collaboration between the government and the companies. If I take the example of the French government, they build industrial base in 20, 30 years. And it's not only LSI, the large system integrator like Airbus and Thales, but it also all the supply chain to build in order to make some military SATCOMs, for example, Syracuse, you need a natural base for 20 or 30 years.
I was just wondering, obviously we've got a very European-focused audience here, but from a Lockheed and a Northrop perspective, where you're operating in Europe, but also you've got significant customers in the US, is there anything you can sort of compare and contrast between how you see the US dealing with these sorts of challenges of innovation and supply chain versus how things are being done in Europe? I think, John, you had a view on how Lockheed's using SMEs to innovate and accelerate and things like that.
Can you hear me? Yeah.
Yep.
Sorry. So I think even for large corporations, it's still a challenge to effectively establish a footprint. The barrier of entry to the satellite manufacturing market is huge. So it takes an enormous amount of capital investment up front. And for the reasons we just mentioned, there needs to be a business case behind that to close it. So if we need to grow the UK industrial base through innovation, I think government could help with kind of thinking outside the box a little bit, perhaps, with respect to sort of T's and C's, rather than can you go and build some of these satellites? A bit more thought into, okay, well, how could government help stimulate growth by, through maybe contractual T's and C's, I won't get into detail here, like trying to think of innovative ways contractually to bring more players to the market. So not just Lockheed, Airbus, Northrop, but perhaps there could be another 5, 6, 7, 8, 10 other satellite manufacturers which potentially could come to parts of Europe and the UK if somehow that barrier of entry was lowered. So I think we're in danger of stifling that growth.
Yeah, I mean, yes, come back to sort of difference between the US customer and other customers. I mean, the US clearly has a scale. It has a pretty large budget, etc. So that's the difference. And sort of coming back to Don's point and the space threats, I see there's it's difficult to do, but I think there's a future where we need to look at collaboration across the allies to say, we are all facing the same threat. So can we bring together, and this is something for governments to do, it's not for industry, but can governments come together and say, actually, let's build this next fleet of satellites or the space domain awareness sensors or the space control payloads, try to do it together. Because then you can come to industry, and in industry, if we can get certainty in bigger programs, that's where we can drive costs down and we can get more reliability. To Don's point, you're trying to scale up things. If you can do that, that's how we deliver wins for everybody.
Yeah. So, May I? So this is a really interesting point. Can you manufacture so that we can have sovereign when necessary and interoperable when possible? This is, I think, in Europe, the great big challenge with IRIS Squared and everything else. Interoperability is what the United States wants. It wants to be able to move data more quickly to its allies, right? Right, John, you would agree with that. And so can you be sovereign and interoperable in the context of Northrop Grumman?
Yeah, so I think this is, this comes back to, at what level do you share things? So, could each country have different hardware on its satellites, but actually it's the data layer where you're sharing. So, you don't all have to have the same thing. So you may build the same things, different things in different countries in your own industries, but then you share the data, potentially at different levels of classification. There might be one club that shares at some levels and some at another. So it's how to put all of that together. And some of that is already done. So in certain missions within space, that is already done across the allies. But it's about broadening that out and becoming more, I guess, more open to, as you say, that's how to do it.
By the way, I'll note, I'll throw it to you. I'll note that Surrey Satellite Technologies effectively invented, now an Airbus company, effectively invented small satellite applications. And Sir Martin and everyone there were my heroes back in the day. And you talk about how you can have lots of manufacturing in country, in the south of England, as a part of the space industrial base. There's a great story.
Sorry, it's an excellent example. Yeah, SSTL. I continue. It's not a history lesson. They're doing some great stuff, particularly with Space Command in this context here. And for us, it's great to have a subsidiary like SSTL, not for just complementing what we do, but to enable us to experiment and to test, to demonstrate technology and so on, but also to complement. But yeah, I think there's room for all those approaches. It's a complement.
Okay, thanks, Dave. Have a good journey back, and thanks for joining us.
Yes.
So, I had one of the other areas we wanted to explore amongst the group was about how industry at your level is addressing some of the threats out there. Like we touched on before, we're all worried about the same suites of threat. That costs a lot of money to try and mitigate those issues, and if we do them in a national way, that perhaps leads to expensive bespoke solutions rather than, like I think Michael, you were talking about, if we were to, and Dave, do that more collegiately across a wider group, that would help to bring the costs down. So what I was wondering, and it can lead into my question to Clint in a moment, is are you getting enough information from governments about the sort of the threat parameters that you need to be defeating? Or do you think that industry has to somewhat guess at these things from the information that you can gather? And I kind of sense sometimes there's a lot closer relationship between the US government and some of the US manufacturers than there perhaps is between European governments and European manufacturers. And an example I wanted to kind of think about was, Clint, you were talking about the speed at which these Chinese satellites are moving around. Now, if you were to try and defeat that with a traditional satellite, you'd probably break the solar panels or the antennas would drop off or something like that if you were trying to steer it around at 80 meters a second. So has anybody actually come to EXO and said, hey, how fast are these Chinese satellites going and how fast do we need to go to defeat them? And then come to a manufacturer and say, right, we need you to build something that's going to withstand a maneuver of, 80, 90 meters per second. Do you see that conversation going on?
I have no idea. Oh, there we go.
There you go.
Well, I wish you'd give me the question before. You told me you might ask one. I wish I'd known it before, but I can only answer for myself, and I'll say yes, and I'll use Northrop as an example. So Dave's colleagues in Northern Virginia saw this variation of this talk 4 years ago, and the next week I was in their manufacturing facility with their designers going through it, and they were saying, well, what would it take to counteract this behavior? And I don't know from an engineering standpoint how you design a satellite, but I can tell you the types of maneuvers you need to do to counteract another maneuver. And they took it seriously and started looking at their designs, like how would we do that? And that's just an example. Dave's on the stage, but I've done that with several companies. And it's sort of I think it's a serious question. How can we protect ourselves? We're all having that. We think about that. So we ask our cyber colleagues, hey, how do we do this better? So I think every company is looking at how to get better at those things, for sure, and we've done it many times.
And I think what's key is to try and think ahead, isn't it, and try and think of what are the future requirements need to be based on what we think that future threat is, rather than perhaps, right requirements based on past experience, because that's where we're more comfortable. And those sorts of things. So I was just kind of wondering, on the back of that example, how much have you guys as manufacturers seen customers come in with requirements that really move us on in terms of capability to meet those threats? Are they pushing the boundaries from their own perspectives, or are they saying to you guys, well, come on, you tell us how to do it? Where's that relationship at the moment? John,
I think
nodding a lot.
Comes, I think, kind of back to the comment I made before. So it's around what is the problem to solve and not being too prescriptive. So, for example, how the UK would perceive the threat environment. I've got to be careful because obviously I'm going to put through the shredder on the way out. Is how the UK would see a threat environment is potentially different to how the US would see a threat environment, which is probably different to how France, Germany, and Spain and other countries perceive the threat. So without being given the problem to solve and something prescriptive, it might work for one country but not another country. So thinking about how government could help with this, potentially it's easy to say, maybe even at a NATO level, if there was like a quarterly threat briefing or review where we could try and gauge what the common themes are across the threat environment for all countries. And it kind of gives satellite manufacturers a bit more sort of meat on the bone to target their internal research and development funding, because there's danger that we could be spending a lot of money but not in the right areas. But if we don't know what the right areas are, hence the suggestion of some kind of working group, then potentially we could end up with something that's very expensive, doesn't fulfill all of the requirements, and potentially could go out of date pretty quickly. So,
I mean, just from my side, and this isn't a discussion we particularly have with the customers, but I think we all realise now that space is becoming a war-fighting domain, and potentially as space professionals, I think we see the threats, and typically we straight away go to, okay, what technology can we use to deter that threat? But as we see in other domains, there are principles of warfare that perhaps we're a little bit slower in the space environment to look at. So decoys, deception, deterrence. So those things, we were having a conversation earlier with a colleague of, if you put something on the side of a satellite that just looks a bit weird, next time somebody flies past and has a look, maybe they don't know what it is, maybe it doesn't do anything, but is that enough deterrence? Are there different things that we should be doing in the space environment that we've seen in the land environment particularly, blow-up tanks look just like a normal tank when you're flying over. Should we have decoy satellites? So I think we need to widen the aperture of how do we address the threats?
Yeah. And I think, go on, Michael.
For me, it's an important issue, of course. When I was in the French MOD, I had to deal with Luchtramp. so with Athena Phillips, the French satellite, so of course it's an important issue. For me, it's discussions between the manufacturer of satellites and the MODs, because it's a MOD issue. And for me, you have a different form of answer. First, it's a modification of the satellite, so you can add some additional capability, sensor, for instance, but also propulsion in order to have the same capability of the aggressor. You can also have the exterior help, is the bodyguard satellite with the capability to protect your satellite, and this bodyguard can have some, laser or radio frequency jamming. And for me, there is a third thing which is very important. We have a very important support from the government for in-orbit services. Thales is implicated in EROS, the European project. And with this new capability, you can have refueling, but you can have also a change of sensor, maintenance on board. And in case of regression, I think it could be an additive functionality. Today, in orbit services, it's a real technology. It's the new generation of a satellite with dedicated interfaces. And if we have this type of satellite, we could have the capability to change some sensor after an aggression, for example.
I was just wondering from a manufacturer's standpoint, whether something like a theatre entry standard for NATO space assets would be beneficial to help then corral or at least give you a common set of baseline requirements. It's like if you're doing a fighter jet, it's going to have electronic countermeasures or a radar warning receiver or an infrared type cable. You know that you've got to go into a battle space with these things as a minimum, a refueling boom and those sorts of things. And it's perhaps not too dissimilar to the space environment where you think, well, there are threats from lasers and radars and things like this. So perhaps as a minimum baseline requirement. There ought to be some definitive standards around those sorts of things. So the manufacturers, you know then where to aim for, and governments perhaps, can come up with a consolidated view. And that perhaps feeds back to what we were talking about earlier. It reduces the cost across the board because you're focusing that money where it needs to go to, into a common set of capabilities. Okay, small adaptations for particular national reasons or whatever, but probably do that through crypto and chipsets and things like that. But maybe that, would you see that as perhaps a beneficial thing that could be facilitated through NATO or some other international organisation?
So I think there's one kind of key requirement, almost like a Rosetta Stone for interoperability. And I did ask a question 3 or 4 years ago, Global Mill Satcom, head of NATO Satcom, and it's quite simple, really, simple baseline requirement, and that's, could there be such a thing, perhaps through NATO, to create a optical inter-satellite link standard? So effectively, then if everyone's using the same kit, same wavelength, effectively allowing everything to talk to each other. So just that one standard could open up a huge, allied by design, and the resiliency benefits are huge as well. So it would be great one day to have Kuiper talking to O3B, talking to some Airbus, Lockheed, Northrop, Grumman satellites, and literally it would just happen, easy to say. But if we get this, also a transport layer as well, so getting that common standard, I think that one common standard, easy to say, but I think that could unlock a huge amount of potential.
I support that very much, right? And in the meantime, this year we're flying for NASA a translator satellite. So the translator satellite takes, until there's that standard, takes different optical ISL inputs and is like the translator in a UN translator booth. Says, okay, we'll output in these optical ISLs, actually having to have the hardware on board. And that's a workaround until you get to what you want, which I fully support. There should be an OISL standard that we all use to speak to each other.
So anyone, NATO, would you like to make that happen? So probably not a 5-minute job, but I think that would be really powerful, a lot of benefits.
If I think to the possible baseline, we can have some disruptive technologies which could be included in all the future satellites. For example, we can imagine cyber automatic detection on board, on cyber reaction on board, automatic. But we can also have the possibility to have a new cryptography in order to reinforce the telemeasure, the telecommand links. For example, we can have hybrid algorithms based on pre-quantum case and post-quantum case. It could be the common baseline of the next satellites in order to deal with these threats.
Cool. All right. Well, look, I think we're nearly up for time. So thanks a lot for real interesting perspectives from the manufacturer's point of view about some of these aspects. We've got a few minutes for any questions. I'm not sure how we'll get those through, but if anybody's got any questions, we've got a couple of minutes left that we can put to the panel. Anything? I can't. There's a hand there, but it's very difficult to see.
Sorry about that. I'm all the way in the back. I maybe should have stand. So my question concerns a potential scaling for any need. As we saw with the Ukraine conflict, our ability to produce the required shells was not necessarily where it needed to be, and there's been some struggles to get scaling to that capacity. So my question is for you, what can the Space Defense Industrial Base do ahead of time to, say, prepare for any scaling in your capabilities, either terrestrially or in orbit, as needed in the event of a conflict? Thank you.
So I guess that as you were talking there, I think there's an interesting synergy with the ability to launch. Obviously, you can make a satellite, but you've got to get it into space quickly. But actually, that market is changing quite rapidly as well. You know, costs are coming down, launches can be done more frequently. So, you know, it's not improbable to be able to replenish space assets quickly because that launch market is there. But like you say, you've got to have the supply chain and the satellite ready. Interesting example from the MOD, the reason why we had a couple of extra Skynet satellites put up was you could keep them spare on the ground, but they're not really doing anything, so why not put them up in space to start with? But somebody's got to pay for that and have the capability there. So, Dave, what's your view on how that particular issue can be addressed?
Yeah, I think the challenge, I think it's a very, very good question. I think the challenge for industry to do things ahead of time is, it comes back, and Dave mentioned it before he went, things have to have a business case. So it's very difficult for industry to invest speculatively for a requirement. So again, it comes back to that collaboration. But I think what we have seen with some of the challenges in the supply chain over the last few years, we've moved away from, this is across many industries now, from sort of the just-in-time supply chain with no inventory to coming back to supply chain resilience, which that in itself is beginning to grow that sort of scale. So actually supply chains are a little bit more resilient, manufacturing is a little bit more dispersed. So we're sort of growing it, but can we do things ahead of time? It's difficult just as industry. We could certainly do it with government, yes.
Yeah, I think what you're addressing actually is a change in the space business. The space economy and the space business for governments has got to move from a reactive to a proactive. And so therefore, if you see a threat environment and you need to support XYZ missions for your warfighter, well, anticipate it. Be proactive, because the space economy, as Dave said, is changing so much, it is not inconceivable as it was maybe 20 years ago. So proactive, reactive approach to scale. And that will be good for everybody on this panel.
Mickaël?
I didn't mention it, but we have a arrival of the new space ecosystem. And today, I think it's a complementary LSI and startup, and we can help to have a specialization of disruptive technology built by startup. And with the help of LSI, we can bring it in the satellite in order to be reactive.
Yes, I think as well, perhaps there's another take on this, because like you say, there needs to be a business case. If you're going to have something spare, ready to go, there needs to be a business case. That's going to cost a lot of money to have. And maybe another way of addressing the particular point you raised is incorporating the need for that ability to respond into core requirements of a program. And as we see the industry change, technology is changing very rapidly. So maybe we won't want big satellites that sit there for 20 years. We might want smaller satellites that are swapped out every 4 or 5 years. But also considering the need for replenishment, you come up with a program of satellite launches and capability developments that enable you to have some element of overlap and be able to either delay a satellite until it's needed or bring one forward in the manufacturing process, because manufacturing is faster, you're building something smaller and less complex, and have a more regular battle rhythm as a natural part of your program. But if you have lost something through a technical fault or a space weather event or some other environmental problem or a hostile attack, your program is actually operating at a pace that enables you to perhaps bring something forward by 6 months instead of having to go to the drawing board and say, well, it's going to be another 4 years until we've got a satellite up there. And maybe incorporating that, the risk of not being able to replenish into a program leads to a systemic solution perhaps. But that, I think, has probably got to be customer-led as a requirement, because ultimately they're the ones that are going to have to live with that approach and the costs associated with doing that, but perhaps that's a way to do it.
I have an example of reactivity. In Thales, we have created the Space Business Catalyst with an accelerator of startup, on a small internal venture. And it allows us to send a satellite with 3D printing. So we are proactive in this case.
Yeah. 3D printing is very exciting. And in terms of proactive, shout out to Melanie Delanoy, the brilliant organizer of this entire event, who continues to amaze.
Yeah, well done, Melanie. Right, that's time up for us. So thanks a lot. Thanks for the question. And thanks for the engaging conversation. And yeah, thank you, Melanie, and the team behind setting up the event today. It's great. Cheers. Thanks, everyone.